Hey there, I'm going to work this number one from your inclined force practice problems to kind of give you an example on how to work these problems. So number one says we have an 8 kilogram box, it's at rest. So I'm going to underline that because remember that means we have balanced forces. On an inclined plane, it makes a 30-degree angle relative to the horizontal, and there's no friction on the inclined plane, and the rope holds it at rest. Again, it is at rest, so we're balanced forces. And so for part A, we need to draw a free body diagram showing the forces on the object. And we know we have Fg that goes straight down, and tension is holding it up. So tension will go parallel with the ramp. And then normal force is going to be perpendicular with my ramp. So there's the forces that are on the object. And if you remember from the notes, we shift our x and y axis. Okay, so my y is like this, and then my x is like this. Okay, so if I kind of drew the dotted lines there for my x and y axis, it would look like this. So your normal force runs it parallel with your y axis, and your tension runs parallel with your x axis, leaving your Fg to be the only angled force. And so for part B, they tell us to resolve the weight into the x and y components. And also, if you remember from the videos, notes, the angle that your ramp makes is the same angle that we use when we resolve our x and y for Fg, for the weight of the object. And so looking at this, if we kind of expand on the triangle for our Fg, so this would be my Fg, and here's my Fgx, and here's my Fgy. And so to resolve these, let's start with the x. So x, the Fgx, is opposite that 30-degree angle. So we're going to use the sine function. So if I wrote it out, sine 30 degrees, it would equal Fgx over Fg. So your Fgx is just equal to Fg sine theta. And so then we can plug in, since our mass is equal to 8 kilograms, that means that your Fg is equal to 80 newtons. So we're going to have 80 sine 30. And so that's going to be my Fgx, and if you plug that in, you end up with 40 newtons. So there is my Fgx. And for my Fgy, it is adjacent to the 30-degree angle, so we would use a cosine function. So your Fgy would equal Fg cosine theta. So that would give me 80 cosine 30. And if you plug that in, you end up with 69 newtons. And then for part C, it tells us to write a net force equation in each direction. So in the x direction, we have tension pointed up the ramp, and then we have our Fgx pointed down the ramp. And so if I drew that here, it would look like that. So it's pointed down the ramp. And since it said it was at rest, that means everything is going to equal 0. So for the x direction, we would have tension minus Fgx. And so I'm going to expand a little bit on the Fg. Instead of just writing Fgx, I'm going to write what it is equal to, right? So it's Fg sine theta. And the reason why I'm going to write that out is because here later, that's going to be beneficial, because there's some times where we need to actually even write that as mg sine theta. Okay, and you'll see why on inclined force 2, because sometimes we end up needing to cancel out that mass. And so for for the net force in the y direction, we would have our normal force minus your FGY, okay, because the FGY over here is going in this direction. And again, I'm going to expand that. Instead of just saying FGY, I'm going to use this right here. So FG cosine theta. And we know that these are also equal to 0 because the object is at rest. And then for part D, it tells me to use the sum of the forces in the x direction to calculate the tension. So tension minus that FGX or FG sine theta was equal to 0. So that means that the tension is just equal to FG sine theta. And we found that right up here, and it was equal to 40 newtons. So the tension is equal to your x component there. And then it says for part E, use the sum of the forces in the y direction to calculate the normal force. So based off my net force equation, we know that the normal force is just equal to Fg cosine theta, that y component, which was 69 newtons. So this should give you enough kind of guidance to go through and finish the rest of incline force 1.